Hey guys, welcome to the video today. Well, this video is more of a supplemental video. You talked in class about special solutions, infinite solutions, and no solutions. This video is supposed to be there to help refresh you in case I'm working in the math house right now and my colleagues are going to be throwing me grapes. So I might be catching my mouth as we go. So this is designed to help refresh or reinforce your understanding of this material. So remember we talked about how 95% of our equations we solve with a single variable are going to have one solution. Most times x will equal number or y or whatever it is. Such as the example we have here. You can see we distribute, we get rid of the constant, we cancel the coefficient, x equals -5. We have one solution, right? And so -5 is the value that makes the equation true. Reminder, because when we plug it back in, it makes the left-hand side equal the right-hand side. There is one solution. But what happens when, we have something else going on in the equation? So if we look at the equation on the left, it looks normal. It looks similar to something we've seen before. But as we start solving it, something happens there. We end up with -20 equal to -9. And the equation on the right, when we distribute and start canceling our variables on both sides, we end up with -64 equal to -64. Notice the same thing happened in both equations. We can see the variable terms completely canceled each other out. Well, when that happens, what do? How can we find a solution if we do not have any variables left? The answer is our special solutions, right? If the variable terms in our single variable linear equations completely cancel out and the resulting equation is true, there are infinite solutions. Our example before, we had -64 equal to -64. That is a true statement. Those things are equal. So because that's what we were left with, we ended up with having infinite solutions, right? And if the resulting is false, such as -20 equal to -9, those are not equal, they're not the same number, we end up having no solutions there. So this is going to be an important fact to remember when you're taking the quiz, the test, working on stuff. Most of the time it'll be one solution. Sometimes it'll be infinite. Sometimes it'll be no solutions. And we've got to make sure we're watching out for those. So what does it really mean, though, to have an infinite solution or no solutions? Well, let's talk about that. So if you have an infinite solutions system, or infinite solution set of solutions here, what that means is you can take any number in all of existence, substitute it for the variable, and the left-hand side will equal the right-hand side. It is impossible for you to end up without a true statement, without a true equation. And conversely, no solution means in all of the numbers that you could possibly come up with, not a single one will make the left-hand side equal to the right-hand side. Right, and so this is what we really mean when we talk about solutions. Again, we're always tying it back to, does it make the equation true? Does it make the left-hand side equal the right-hand side? So here are a couple things, equations to practice on. You're going to end up with either one, no, or infinite solutions when you try these equations. So go ahead, pause the video, and try these now. Welcome back. Let's see how we did. So the first equation we can see was one solution. We got x equals 4. The second equation, we ended up with 9 equals 9, which is a true statement, so it's infinite solutions because the variable terms canceled out. The third equation here is no solution because the variable terms canceled out, and -8 does not equal -10. That's false, so we have no solution there. Well, that's the end of the rainbow, and as you can see, I thought there was a pot of gold, but apparently it's just a 1994 Ford Explorer. So, enjoy. We'll see you next time.